Okay, so here we are at day 2. So let's see what happened. I will say this is getting big, and sometimes in this picture here, it doesn't look so big, but if you look at, because it looks so much bigger, then I take a picture and I'm like, that doesn't look like anything. But if you look at kind of like the distance, you see this little like indentation on the bottom of my container, that might give you an idea about how this is growing. Okay, so again, we're gonna look at the same questions. So here's where I tried to stretch it out there and get you a good answer. Okay, so here's our data summarized from day 1. I'm going to keep it in the chart, but I'm really going to be looking at back to day 0 to day 2. Okay, and then I am going to look at this relationship to answer these questions here. Okay, but I really want my percent of increase. I'm talking about from the original. Okay, all right, so if I look, and I think I need to make this bigger. There he is. Let's see. Not sure if you'll be able, yeah, I guess you can make your whole screen bigger, right? I think if you do like Control Plus on your Chromebook, it gets bigger. And I think I knew that because one time I thought I was hitting the Shift key and the minus key to get like a line for whatever document I was in, and I was on the Control key, and I made my screen super, super, super small. And yeah, it took me a while to figure out how to fix it, but I did. All right, so again, there's a gap here. So if I kind of go to his nose and follow him over, was I going to do that? Hang on. Hold that thought, because I thought I already measured this. Okay, I guess I didn't look at this correctly. It's fine here. It's just the day 3 slide that I just did. I'm going to need to go fix. But that's okay, because we really want this to be as accurate as possible. So there's like kind of his nose, and if I follow it over, it looks like 13. Well, that's weird. It's hard to see. Oh, because I'm in a highlighter. 13.1 it looks like to me. Right. Okay, because my toothpick doesn't quite hit his nose, because like I said, it was hard to do that. I only had 2 hands, and I really needed 3 at that point. Okay, so I'm going to go with 13.1. Now, if you got something else, I'm not saying you're wrong. This is all like, science, investigation. But you will do the same math that I'm going to do. You just might have a different answer or different numbers. Okay, so this was 13.1. So now let's see again what our factor is. Factor again means multiplying. So I'm going to squish this so I have some room to write over here, because now I have a question. Okay, so I know that 7.2 times some number, which I'll call k because I am thinking about how is this scaling, has to equal 13.1. Okay, so then I divide by 7.2, or I know you guys say like, well, if I'm looking for what I multiply 7.2 by to get 13.1, then I divide, and that's great, exactly. The reason you do that is because of this algebra here. And like I said before, if you watch the other video, which hopefully you were doing these in order, sometimes people divide them upside down or the wrong way, so that's why I like to write the equation. Plus, it's going to help next year in algebra when we talk about track variation again. We're going to really focus on the equation. Whereas this year, we did it, some of you used the equation, some of you used unit rate, and some of you just used your ratio table, which is awesome. All those are very valid. Okay, so anyway, I keep babbling on and on. Kind of like we're in class, yes? All right, so 13.1 divided by 7.2 lets me get my calculator, because like I said, I did this not correctly. I had gotten 13.6, but I forgot about that little space between my toothpick and his nose. So when I do that, I get 1.8194 blah, blah, blah. So since I went to 3 decimal places before, I'll go to 3 decimal places here. And that'll stay in 9 since 4 is less than 5. So that's my factor. Okay, so from the original, let's think about what all this means. The first day it grew 1.375. Okay, So from day 0 to day 2, it grew 1.819. So we could figure out the difference between day 1 and day 2, but I kind of always want to go back to the original because that's going to help us when we apply this to problems with percent of increase and decrease. You got to start with your original. That's the super important one. You got to know where you're starting to figure out where you went. Okay? All right, so 1.819 is my scale factor. So that means I multiplied that by 1. Oh, point. I have a little arrow keeps coming up. All right, hang on. Let me move this down. Oh, now I can't move this. How weird. There it goes. Oh my goodness. Okay. So 1.819. So then I'm going to have to divide or multiply my percent by 1.819. So 100 times 1.819 is 181.9. Okay, so what was the percent of increase? Well, I know it's an increase because it got bigger. It went from 100%, its total amount, to now 181.9%, which I really want to call 182, but we'll keep it 181.9. So what is the percent of increase? Well, I went to 181.9 and I started at 100%, which gave me an increase of 81.9. Okay, so that's my percent of increase. Okay, so I'm trying to think on the other one. I think I wrote out the sentences. So let me write sentences for you. Sentences are good. I'm going to add another page. Back here. Yes, we have to do, is this toy growing proportionately? So to see that, we're going to need to go back and remember that from here to here, use green, this was 1.375. So if it's grown proportionately, then this should also be 1.375. Okay, so let's check that out. So I'm going to just come down here and do 9.9 times 1.375 on my calculator and see if I get 13.1. Okay. And I get 13.6125. So that is not proportional. So we can come in here and say no because of the scale factor. So because of this. 9.9 times 1.375 does not equal 13.6. So remember, if it's going to be, let me get a new screen here again for you guys. If it's proportionately, which I don't know, could be because I didn't necessarily do every 12 hours. I would have been at 2 a.m., which a lot of times I'm up, but I wasn't, so it did soak a little bit longer. So that might be something maybe if you wanted to investigate, when the world goes back to normal and we're allowed out of our houses, if we want to go to a Dollar Tree and buy some and really time it. If we go back to school, I'll do that. I'll get another one, and that way every second period that will be exactly 24 hours, and we can see if it does grow proportionately, because not having these days occur at different times probably affects, I would think that would affect the growth. Okay, so this might not be very scientific, but the important part is, do you understand where that number is coming from? And if you're like, yep, then you have reached your target and we're good for the math side of this, okay? All right, so proportional. Then every time I go from, I'm sorry, I can't remember the number, 7.2, right? To 9.9 is a factor of 1.375, which means if this is proportional, every time I go up a day, I'm going to go up a factor of 1.375, and I didn't. This would have given me 13.6. This would be proportional. Okay. The other thing is if I would graph this, and it's going to be probably, I hadn't thought about Desmos, because you're going to have to make your scale go by 0.1, so it might be hard to see. These will not be in a line. You'll have 7.2, 9.9, and 13.6 would be here, but it's going to be kind of here. So it's not going to be very linear, or it's going to look linear, but it won't be proportional. Okay? All right, so here's my, so what did I ask for the factor? By what factor? So the toy, sorry, grew by a factor of 1.819 from its original. Okay, and then we can say the percent of increase. So let's do this. How about that? This represents a, sorry, a percent increase of 81.9%. Okay? Alrighty, so make sure we answered those. My work page is going on. Alright, so again, I'll post one more tomorrow, which would be Thursday. Yes. And we'll see what happens then. Okay.